Hello everyone, in this presentation we are going to understand how to interface a temperature sensor with RP2040 carrier board from Vi-Microsystems. You are able to see the temperature value in degree centigrade is displayed in the LCD display, the temperature in degree 30 degrees centigrade. So the temperature sensor available in this RP2040 is LM35, which I am highlighting here. So this temperature sensor is producing the 10 millivolt per degree centigrade, as we know very well. If the room temperature is 30 degrees centigrade means, so it is giving 300 millivolt. The given 300 millivolt is converted to digital with the help of on-chip 16-bit ADC, and then after converting into the corresponding integer, it is getting displayed as 30 degrees centigrade. If you look at the code, we can understand it clearly. So for computing the, for interfacing the pin, we are bringing in the pin function from the machine library, and then we are using LCD, so we are bringing in the GPU LCD function from the GPU LCD library, and then we are importing the time for necessary time delay requirement. So as we are very much clear that there is a 16-bit on-chip ADC, onboard ADC is available. So because it is 16-bit onboard ADC, the infinite values between 0 to 3.3 volt. What is 3.3? The maximum voltage of the RP2040, that is VCC, which is our maximum V in. So this is the resolution, right? So 3.3 divided by 63536 is nothing but the resolution of the ADC. So the infinite values in analog from 0 to 3.3 is converted to 63536 finite values in digital. Hence 3.3 divided by 63536 will be the conversion factor. That is what you are able to see here in the screen. And then the 27th pin, that is 27th GPIO, as you see in the screen. Here you can see the 27th GPIO. If you look at the screen, 27th GPIO is ADC1 in RP2040. So the temperature sensor output, LM35 output, is connected to 27th pin, which is configured as ADC pin. So the alternate function of GP general purpose 27th pin is ADC1 pin of RP2040. The LM35 is connected to ADC1 of RP2040. So that is why the ADC2 it is configured just like this. And then as usual, we are initializing the LCD, where the register select and enable is connected to 8th and 9th pin of the RP2040, and the data pins, 4 data pins of LCD is connected to 10, 11 and 12th and 13th pin of this LCD. So 6 pin of RP2040 is connected to LCD. And then within the while loop, we are reading the ADC value. We are reading the 16-bit ADC value to the variable value 2, and then we are converting it into the integer value. So the value 2 is multiplied with the conversion factor, and then it is rounded off by multiplying it with 100, and then the integer value of the temperature variable is given to the temp1, and the string value of the temperature 1, that is given to the temperature 2. And then, as we know very well, in the first row, first column of the LCD, we are displaying the string temperature in degree, as we see in this LCD. And then in the second row, first column, which is LCD.move _ to 0, 1 means 0 means first column, and this 1 means second row in the LCD. So in the second row, first column, we have to put the string of temp2, which is nothing but the integer value of the temperature, red temperature, and then we are waiting for 0.3 seconds. Once in 0.3 seconds, the temperature value is keep on getting updated, as you see here in this LCD. So the temperature shows 30 degrees centigrade. If I hold this LM35, my hand temperature is a little bit higher than the room temperature. So now you are able to see the temperature value is keep on increasing from 30 to 34. Now I just removing this hand means temperature may gradually decrease from 34 to 30, which is going to be the room temperature. So this is how the any analog input can be given to the RP2040, and then the analog value can be converted to digital with respect to on-chip ADC, and then we are able to display it in an LCD in the carrier board. So on board LM35 temperature sensor and onboard LCD help us to monitor the room temperature. So any temperature monitoring applications, this carrier board will be very much useful, and we can make use of this board for doing similar applications. So RP2040 carrier board is very much helpful in interfacing temperature sensor also, because of the presence of on-board LM35 temperature sensor as we see here in this experiment. Thank you.